What is good, everybody? Mr. Martin here, Mr. Martin's Math Corner. We are on 10.1, Anatomy of a Quadratic. All right, so we have been talking about quadratics for quite some time. In this section, we are going to talk about the anatomy of that quadratic. And when I say anatomy, that means we are going to be looking at it graphically. There are specific parts, key parts of a quadratic that tell us a lot of information and are very, very important. So we are going to look at those, we are going to talk about them, and we're going to describe what these properties mean for our quadratic functions. All right, so we got a little bit of things to know, some good vocab up in here. This one's a little bit of a recall, but just remember that a quadratic, this is a polynomial that has a degree of 2, okay? And when I say degree, remember that means exponent. So if we're looking at the highest exponent of our polynomial and it is a 2, then we indeed do have a quadratic. Okay. When we had linear graphs, they were just straight lines. Here, when we graph quadratic, we have what we call a parabola, or it is a shape that is parabolic in nature, and you will see what that looks like here in our next example. Okay, so this might be new for us. This is what we call the vertex, and this is our highest or lowest point on the parabola. And I say this highest or lowest because based on what our function looks like, we might have a high or we might have a low point. Okay, and last but not least, we got this thing called the axis of symmetry. Remember, something symmetrical means it looks the same on both sides. If I cut a ball in half, it should look the same on both sides. Forgive my precision here. I know these are not equal, but you get the gist. Okay, but in our case for math, when we talk about the axis of symmetry, we are talking about the equation of the vertical line. And I say equation again, just like that, equation, because when we describe the axis of symmetry, it is an actual equation. So you'll see how I write that when I'm asking for the axis of symmetry. And this just creates symmetry on the graph of our quadratic function. All right, let's take a look at what a parabola looks like. Ta-da! Okay, so there's many different things that are parabolic in nature. I'll probably ask you to share some images with me of stuff that looks like parabola, because we actually do find this in nature all the time. It is a very, very real world concept. All right, so typically this function would come attached with the actual algebraic function next to us. For this purpose here of just identifying the parts, we don't really need to know what the actual function is. We just need to know what this parabola looks like. All right, so I'm going to do this thing here. I'm going to start with the axis of symmetry. Okay, if I wanted to cut this parabola in half to where it looked equal at both sides, right? Imagine this. Imagine you were cutting a triangle in half. Where would you start to cut your triangle? Well, you would probably cut from the point and go down. So that's something similar we can do, but do not get a parabola confused with a triangle. This has a rounded tip. Okay, so I'm going to cut at that rounded tip. All right, let me get my line out right here. I'm just going to go a little bit below because I like to draw from bottom of the graph to the top of the graph. All right, boom. Okay, so this is my axis of symmetry, and then I'm going to do this here. I'm just going to draw this line right here and connect it. And then I'm going to label this. Presto, just like magic. You see how that appeared? I paused the video and typed that in so we could save some time. But so I labeled this. This is our axis of symmetry. That is that vertical line that cuts that parabola in half. And I put this little note. It will always have one. Every quadratic will have an axis of symmetry. All right, so let's find our next piece that is important to us. I'm going to grab my line again right here, and I'm going to point to this guy right here. Let's do this. Bam. Can you guess what that point is? This is our y-intercept. All right, let me go ahead and label that up for you as well. All right, look at that. So I labeled this as the y-intercept, and again, I denoted down here our y-intercept. It will always be there. So every quadratic that we have will always have one y-intercept. So we always have one axis of symmetry. We always have one y-intercept. All right, let me do our next one. Let me point to this guy right here. Okay, and then this is what we call our vertex. All right, look at that. So we have a vertex, and our vertex is always going to have 1. There will always be one vertex. And let me add a second note in here. 1 second. All right, look at that. I changed that up. So it always has 1, and it is either a max or a min. In our case here, we have a minimum because that is the lowest point. So if you have something that is the lowest point, it is going to be a minimum. If you have something that is the highest point, then it is going to be a maximum. Okay, and then last but not least, we got these two guys right here. All right, so let me label that up for you real quick. Shazam, right there. All right, so these are the x-intercepts, and then I got a little note here that sometimes it'll have 2, sometimes there might only be 1, and sometimes we might have none based on the type of quadratic we have. So this part is very, very important to remember. Let me go ahead and put a little box around that because it is not always the same. Unlike the axis of symmetry and the y-intercept, the x-intercepts might be a little different based on the graph that you have. So this boxed up piece of information might want to be something that you commit to memory. All right, so these are all of the key parts to our parabola, but we are going to answer some other stuff that we have talked about in the past and we should remember how to do, but they are very important to us when we talk about our quadratics and our parabolas. All right, let's jump into example number 2 and start answering some of these questions. All right, so we have example number 2. It is giving us a quadratic right here. It gives us the graph to the quadratic, and then it asks us several stuff over here to the right. So I'm just going to go through the ones that are very easy to spot, okay? Because sometimes we might need a calculator or some sort of application to assist us in finding out some of the stuff that we need to find out. So this first one, equations in standard form. It looks like it is in standard form. I always like to write it just in case if they're asking me to put something in standard form because it might not always be in standard form. Alright, so I'm just going to write our quadratic here, minus 4x, and then we got minus 10. Okay? So the next part asks us, is there a maximum or a minimum? This is something that we can figure out just by looking at the graph. Well, it looks like the highest part, which is that tip of our curve, is our highest point. So in that case, this is going to be a maximum. Okay, and then the parabola opens up which way? When we talk about where it opens up, we're talking about where the arrows are facing. So our arrows here are facing down, so this parabola is opening downward. Okay, so far we've been able to answer these without any assistance. Okay. Another good one to jump into easily is the leading coefficient. Remember, the leading coefficient is the coefficient of the first term once it is in standard form. So if we take a look, we have a negative 1/2 in front of our highest degree term. So our leading coefficient is going to be negative 1/2. Okay. Remember, the vertex, that is the tip of our parabola. So that looks like that is right there. So we are trying to figure out what this point is, and this is listed as an xy point. So we have our x value -4, our y value of -2. So we list this as an ordered pair, -4, -2. Okay, and with that we can go ahead and cut this down the middle. Okay, so we did that before. So I'm going to do that again here. And this is where I'm talking about we write it as the equation of a line. So at what x value are we drawing this vertical line? We are drawing it at -4. So we have x is equal to -4. Okay. Increasing and decreasing. We've seen this before when we talked about behavior of a graph in our piecewise function unit. So where's the graph increasing? Remember, we always read from left to right. So we look at our x values only because we only talk in terms of x. So it looks like we're increasing all of these values here are increasing until we get to this changing point at -4. So we are going from negative infinity to -4. Okay, and here we're just going to use parentheses for our interval notation because at -4 it is immediately changing position. And then we are decreasing from -4 to, you guessed it, positive infinity. Okay. Now let's talk about the domain and range. Well, we know that the domain is all of our x values, and it looks like this graph is going down. Looks like this graph is going down, but as it goes down, it is also going to the right and it is also going to the left. Okay, this graph will never go vertical. Okay, so if it never goes vertical, that means it is still extending left or right. So we are going from negative infinity all the way to positive infinity. So to write that, we can use interval notation, but you could also write all real numbers. Okay, and then remember our range, we go from bottom to top. So these arrows indicate it goes on forever. So we have all these values down here in the forever going all the way up on our y-axis to this number right here. This is where the buck stops. So we are going from negative infinity all the way to -2, and since -2 is included, we are going to use that bracket. Okay, now if we look, does this graph touch any of the values on the x-axis? It does not. So this is one of those cases where we would have no x-intercept. So our x-intercepts for this graph is going to be none. This is one of those cases where it has none. Okay, and then the y-intercept. We want to see, where does this graph cross the y-axis? Well, we kind of ran out of graph here, so that's going to bring me to this piece right here. What do you notice about this graph? Well, we notice that we're looking for the y-intercept, but it's not showing us enough of the graph to tell us what that y-intercept is. So I have this little piece of information here that says the graph does not visibly show it. How can we find it? Well, we can substitute a 0, because remember, the y-intercept is when x is equal to 0. So if we have some x values here and we substitute those in with a 0, let's see what we would get. Well, 0 squared is 0, 0 times -1/2 is 0, so that would turn into a 0. What about -4 times 0? That would turn into a 0 also, and we would be left with -10. So when x is 0, y is -10, and that gives us our y-intercept. But you can also realize that since your first two terms have x values, no matter what, our c term in a quadratic, the constant term of our quadratic, is always going to be our y-intercept. And this is very important for you to remember and hold on to, because it will help you in the future. All right, so that was example number 2. All right, let's take a look at example number 3. Okay, so we got this quadratic here, the equation in standard form. I'm just going to go kind of quick and start plugging these away so this video is not too long. You've heard me basically explain it in the last example, so we're just going to go through. So our x-intercept, where are we touching the x-axis? Well, it looks like it's coming down, and it looks like it's only at 1 point. So that looks like we are at -1, 0. So this is one of those cases where it has only one intercept, and then our y-intercept looks like 0, 1. If we drew this line to cut it down the middle, and I know I'm kind of just hopping around here, but we can find that axis of symmetry. So that is going to be x is equal to -1, and we know that our vertex is that tip point, so that is going to be -1, 0. -1, 0. Our leading coefficient, if there is no value out front, we know it is always a 1. Okay, what about our domain? Is it the same thing? This one is going upward, right? These arrows are going upward, so let's talk about that. So the parabola opens up upward. Okay, so our domain, well, this is going to continue going up and to the left and up and to the right. So yep, you guessed it, this is also -infinity to +infinity. Okay, and then our range, if we go from bottom to top, all of this down below has no values until we get to 0. Remember, we are talking about the y-axis, and then we're going to continue all the way up. And as this graph goes up and to the right, up and to the left, it is continuing to go up. So our range is from 0 to infinity. Okay, and remember to include that 0. So I want to stop right here real quick. If you haven't noticed, our domain is all real numbers. This one is all real numbers. So what do you think you can generalize about every quadratic? Because this one opened downward and this one opened upward. Yes, you have guessed correctly. The domain will always, always, always be all real numbers. However, the range will vary based on your problem. All right, so let's figure out our increasing. Remember, we are talking about terms of x. Remember, these are in terms of x. So increasing, we start going up from here to infinity. So we are looking at -1 to positive infinity. And decreasing, we are coming down from negative infinity to -1. Sorry, that's almost an 8 right there. All right, and then do we have a bottom point or a top point? It looks like we have a minimum. All right, so if you haven't noticed, I'm going to tell you right now, what is the sign of our leading coefficient with this quadratic here? Here we have a positive, and when the graph opens upward, we were left with a minimum. When the graph opened downward, we were left with a maximum. Okay, so that is another pattern that holds true throughout all of these quadratics, something also very useful to remember. All right, and then what do we notice about this graph? Okay, we talked about how it had only one intercept. Okay, so I left a little key piece of information here. Let's take a look. This is one of our special case sum of squares. Okay, the two factors are exactly the same. If we were to factor this, okay, we would end up getting x plus 1 and x plus 1. Okay, and then we would simplify that as x plus 1 squared. And if we were doing our zero product rule from our last section, we would find out that we have a 0 of -1. And remember, our zeros are where our graphs touch the x-axis. All right, so this is the reason why there is only one. And I'm going to put an asterisk next to here because this is very important to remember. All right, very good. So let's jump to example number 4. All right, so we got x squared minus 9. Okay, so let's put this in our standard form. This is already in standard form. Okay, and we can just start answering this. Well, do we have a max or a min? Well, it's opening upward, so that means we have a minimum. Okay, and I've already answered this question, so I know we're going upward. We already know the domain. We should never get this one wrong. Negative infinity to positive infinity. Leading coefficient is right in our face. That's a 1. Okay, we can draw our axis of symmetry here. Okay, so it looks like we're cutting at what value? Well, this y-axis is an x value of 0. So don't forget, always, always write it as an equation of a line. All right, and then our vertex. So we are looking at right about here. So that is going to be 0, -9. All right, do we have a y-intercept? Well, we sure do. That's actually the vertex. So we got 0, -9. Okay, increasing, we're going from 0, right? This is our x value of 0 to positive infinity. And then we're decreasing, coming from the left from negative infinity, and then we take that turning point at an x value of 0. All right, let's take a look at our range. We are going bottom to top, so it looks like we are starting at -9, and we're going all the way up to positive infinity. All right, x-intercepts, I'd say these look pretty precise. So this one looks like we have 2. It looks like we got one at -3, 0. And then we also have one at 3, 0. So we got 2 of those. All right, we answered all of those parts in that block. Let's take a look at this piece right here. What did you notice about this graph? What kind of function is this? You have seen this before. Boom, let's reveal it. All right, so this is a special case as well. This is the one that we call a difference of squares. And if we take a look, the x-intercepts are the exact same value. They're just opposite signs. This one is a -3 and this one is a +3. Okay, so when we have that special case, we are going to have an axis of symmetry of 0 if these are on the opposite sides. There is another piece that looks identical as well. Can you guess? Well, it looks like these two. Looks like our vertex is going to be the same as our y-intercept. So it is very important that you identify these special cases. Always look for them. They are the Easter eggs of math. All right, and then last but not least, okay, we got example number 5. Okay, if we take a look, let's go ahead and fill in what we can fill in. We know that this is going to be -2x squared plus 12x minus 17. Looks like we have a maximum, so I'm going to write that in. Parabola opens downward. Okay, another piece that I already know is my domain. That is always -infinity to infinity. Our range looks like we are going up to +1, so we are going -infinity to +1. We're going to include that. We have a leading coefficient of, a different one, -2. Okay, our vertex looks like a solid point. We'll come back and check just in case if it is not, but to me it looks like we are at 3,1. Okay. Let's go ahead and draw our vertical line, and then we are going to write in x is equal to 3. And then I want to stop right here. If you haven't noticed already, the equation of the line for the axis of symmetry is always x equals, and that is going to be the x value of our vertex. So something also very important to recall. Okay. So our y-intercept, we did this in example number 2. We can see that the graph is not touching it here visually, but remember, if we always look at our C term, we know that is our y-intercept. So we are going to say our y-intercept is 0, -17. We can safely say that. All right, we are increasing from -infinity all the way to an x value of 3. And then we are decreasing from 3 to +infinity. All right, now if we look at our x-intercepts, let me draw these in green. They look like they're right about here and here. So this is not something that we want to take lightly and just make a guess on when we have things available to get them accurately. So I'm going to show you guys 2 things here. Okay, so the first thing, if you do not have a graphing calculator with you, we can use an application online called Desmos. Okay, so let's go ahead and pull this up. I'm going to go to Desmos.com and let me fit this window for you. All right. So here in Desmos, we can type in our function over here. Okay, so let's do that. So we can do -2x, and if you need to make the squared exponent, you're going to hit Shift-6 on your calculator, and then you can type in the 2, but then you need to get back out of the exponent by pushing the right arrow. That is one way, or you could just simply write 2x's. The platform here will take it with just 2 x's. And then we're going to do the plus 12x and minus 17. Okay, so now it's going to draw our quadratic for us. Okay, and the beauty of it is that when we click on it, you're going to see these 3 dots, and those are going to help indicate some of our values. So were we correct in our vertex? We said it was 3,1. We are correct in our vertex. Okay, so let's take a look at our x-intercepts. Remember, those are where we cross the graph. So this is giving us an x value of 2.293. So let's go ahead and write that one in. So we got 2.293 comma 0, and then we're going to have our second one, which is 3.707. 3.707. Okay, let me go ahead and remove this. What we notice about this graph is that we have a difficult time identifying precisely what those x-intercepts are. So we can use Desmos. However, if you are taking some sort of an examination where you do not have a laptop or computer or phone available to use Desmos, and you are indeed being required to use your calculator, I'm going to show you how to do that here. So let me just pause myself for a moment and get my calculator ready for you guys. Alright, hopefully this looks okay. Alright, so what we are going to do, and remember we have done some of this stuff before, but we're going to put in our function here, and we use that y equals button in the top left to do that. So let's type in the function that we have. We got negative 2x. We're going to square it like this, and then we're going to do plus 12x, and then we got the minus 17. Alright, now what we want to do is hit the graph button. We want to see what this looks like when we graph it. And there we have it. Okay, so the first thing we can do is we can hit this trace button, and when we do that, you're going to see our x and y values, 0 and negative 17. So that actually lets us know we're down here on this graph. Remember, that's matching our y-intercept. So we never use the up or down buttons. We are going to use the left or right buttons. And if we start tabbing to the right, we're going to start being able to see our cursor. And then we can just, you know, run this cursor along. So let's take a look at our first x-axis right here. So if I'm trying to get precisely on it, here I got 2.12, but I'm looking for 2.293. Remember, I want to be really accurate. So as I go across it, it looks like it does not land on there. The closest I get is 2.27. Okay, and that can be a problem. Same with our vertex. Here we got 3.03 and 0.9981, right? We want 3 and 1. So we have what we call this calc feature. Okay, and the way that we use that, remember, anything in blue, we got to hit the second button. So I'm going to hit second, and then I'm going to hit the calculate button. Okay, in this case, we want to identify the zeros. Remember, the x-intercepts are our zeros. Okay, so after I hit that, it is asking me to give it the left bound. So if this is my intercept, I need my cursor to be to the left of that. And I'm going to set it by hitting enter. And now it's going to draw this line for me. And then now I want to put the cursor somewhere to the right of where I'm looking for, which is, you know, maybe roughly about right here. And I'm going to hit enter again, and now it's going to calculate that 0 in between these two lines. So when it says guess, we hit enter a third time, and then it snaps to where that 0 is, and it gives us that 2.29289. So on Desmos, they rounded it up to 3 decimal places, and if we look, that would be correct. 2.29, that 8 will turn that into a 3. So that is very helpful for me. Okay, and we could do the same thing for the right. So if we want to calculate the other x-intercept, we would go to our 0. Remember, we want to be to the left of that point, so I would start right here. And then I need to go to the right of that point, and I would hit enter, and then I would hit enter a third time, and it's going to snap there, and we got that 3.707. Okay, so these zeros are what's going to help you calculate and get that precise x-intercept. Okay, the other thing that we can do with the calc function is we can actually identify the minimum or the maximum. If you look here, it does not give us an option for the vertex. But what do we know about our vertex? Well, if we went back to our notes, we know that the vertex is always a max or a min. Okay, so based on what your function is, you might need to determine if you are a max or min at first. And here we said it was already a maximum, so we are going to choose maximum. Okay, and then it also requires a left bound and a right bound, so I'm going to click to the left of it. I'm going to trace over to the right, click to the right of it, and then when I hit enter that third time, it's going to snap me to the middle there, and that lets me know my maximum is 3, 1, the same as I have on my vertex here. All right, so that is all I have for you guys. My apologies that the video ran long. I kind of wanted to walk through each of the examples for you. Go ahead and do the practice, and if you have any questions, please do not hesitate to reach out. All right, had a blast. Talk to you guys later. Peace.